My name is Kenichi Handa. I'm from ASD Japan. ASD was the national laboratory, but it changed to independent laboratory about 7 years ago. We are working with this person. The core developer is this four. So today I'd like to talk about how our library or our FTL format does complex text layouts. Many agent scripts require CTL, as you already know. For instance, character order is different from grid order. So this is the Devanagari case. The Hindi, this I vowel should be placed before the base consonant. And character change shape depending on the context. For instance, this is the it's Yama case. So this part change something like this. It must surround this part. This is the Thai case. The positioning of just combining groups is very complex. Oh, this T-shirt of the Thai alphabet. Anyway, here this upper dot is this is a single character, but upper dot will be placed before the highest end of the previous character. And the placement of this part depends on the previous character. So the problem of CTL, complex text layout, as first it requires knowledge specific to script. It's almost impossible to have a single CTL program and drag it with different parameters. So we need a different code for different scripts. And currently, or at least a few or 10 more years, we need updating very often. Unicode adds new scripts, Unicode adds new characters to existing scripts, and also Unicode adds new layouting rules. So the CTL program should be updated quite frequently. And when this kind of knowledge is represented in a hard-coded C program, it's very difficult to understand and it's very difficult to maintain. Finally, defined application uses defined CTL code. For instance, DTK uses Pango, Qt is another one, and Automotive uses ICU. So fixing one of them doesn't mean that fixing the others. So half plus will be fault. What is the m17n library? It's a general purpose multi-node text processing library. The library itself is language and script independent. So this C library doesn't contain any language or script-specific knowledge. Those knowledge is provided by external database called m17n database. For instance, character set mapping, character properties, input methods, and those are provided by the database. Today's topic, font layer table, is also one of the database provided by here. What font layer table, FLT character, represent knowledge for CTL. It's quite compact and simple rules uphold CTL by cascading stages. We have modeled the task of CTL through these 5 steps. The first one is the cluster extraction. the cluster is very similar to the Unicode terminology graphing cluster, but a little bit different. Here we use cluster to mean a minimal character sequence with which we can decide their graphical shape. So the first step of CTL to extract this cluster from the character sequence. The next one is the character reordering. As I've shown before, some agent script puts some order before the base consonant. The third step is character prefix mapping. This step means that we change the character code to brief code over a specific font. Then we do brief substitution. It's mainly for related variables. And last, we use brief as brief positioning for combining variables. So this is the case of Khmer CTL, and FLT does these kind of things, mainly by 3 stages. The first one is to extract cluster, this part, and also it does the reordering. And next step, it's 3 and 2 is reversed. The second stage is to brief substitution. Here, this example is for open type font driving. So the character to brief ID mapping is automatically done within the library for handling open type fonts. So now we get this sequence of briefs, and the last step is the brief positioning. We must move this to this place. This stem should just under this part of the base consonant. This is the format of font menu table. It has the category table and generator. And we can have this set as much as we need. So this set, the category table or generator, compose one stage. And for the second stage and the later, the category table can be omitted if we use the same one as this. This category table is a mapper from character to some category data. We can use from A to Z. So we can map a sequence of characters to the same category, or we can map a specific character to some category. And the generator is made of loop. And loop contains the matcher and command sequence. And this matcher can be a regular expression or the segment index of the regular expression or the actual code range. And here, the command you have many built-in commands, and also the rule itself can be a command. So the rule can be nested. Here I'll show how FLT works by using the Khmer OTF. The reason why I use Khmer OTF here is that the Khmer script is quite complicated, but FLT can represent the knowledge for CTL in quite a simple way and easy to understand. So anyway, the first step is the category table. Here we categorize Khmer characters into consonant or two-part vowel or voicing vowel. And also we use these small trainer and trigger. So the input sequence of this Khmer word CAHC category sequence. And this category sequence is very important because it is used in the regular expression matching. C is for consonant and A is for two-part oral, H is poem, something like hiragana or heart, and the last final consonant. Next, this is the code for the first stage. It does cluster extraction and reordering at the same time. Here, we can have this dotted part is just omitted because it's very long and can't fit in this screen. Anyway, here we have a regular expression, and here another. So the sequence that matches with this regular expression is handled by the rule with this described here. So we 1, 2, 3, 4, 5. So the numerical cluster can be classified into these 5 patterns. Now, our input sequence is this one, the previous shown. And this CAHC pattern matches with the second group, this one, second group. So, and C matches here, and AHC matches in these places. This is the command for doing the ordering. I'll explain each one shortly. The first, this symbol shows that we make this pattern as a single cluster. And this vertical bar insert a special code in the output sequence to be used for the separator for the next stage. And here we insert directly one character. It represents the left part of this bar. And the 4, 1, 5, 6 correspond to the segment of the regular expression. So, by using these numbers here, we can easily reorder the input sequence. Here, we move the character sequence which matches with fourth segment as first, but see, in this case, we don't have it. Then we have 1 here, so C is produced by this command. Next, 5, we don't have 5 matching as a segment for 5. And the 6th segment contains AHC4. So as a result, we get this output sequence. The first one, this one doesn't correspond to any grid. This special code is produced by this vertical bar. And we have 17C1 here, and its category code is M. CAHC, and another separator. So this is the output of the first stage. Now we done the ordering. The next stage is next substitution, and we have this code. In this stage also, we use the same category table. So the characters, the M means the same meaning as the first stage. Then here again, we have 3 patterns. And the current example of input sequence, this one, matches with the third group, this one. And this third rule have these commands. The format is almost the same as the previous one. The difference is that we have a special command here for driving open type features. So what it does is so the input sequence MCAC matches with these parts, and these parts is activated. So the seventh part we apply above there. What are they? Seven. A is changed to something by this feature, and HC sequence is changed to something by these row form and post form features. So as a result, we have this sequence. Now, this command also does character to glyph mapping. So here we have a glyph, but there's no corresponding character code. Now these are in the glyph code. Internally, we keep what this pattern corresponds to the original character sequence. But anyway, now the sequence is by a glyph code. But still, we have this part, the separator, and it can be used for the next stage. And the last stage is for glyph positioning. Here also, we use a similar structure, but now the regular expression is quite simplified. The separator and something other than separator and the separator. This pattern sequence is applied to these object features. And as a result, we get this correct glyph sequence. So I quite quickly explained how FLG works. Do you have any question on here?
Yeah, on that same way when you, so the positioning has, I mean the positioning, you're taking that last glyph, you want to position it so that the vertical bars line up. Is that part of what's going on there or not?
This one?
No, the one before that, the last actual glyph.
The glyph?
That thing, yeah.
Yeah.
So is there something that's making it align itself with the one before it? Sorry.
I think you mean that it's applying the open type feature. That says
Okay.
which open
So
type
which
feature.
Which is where? Which is
You mean you use the
Yeah,
open type anchor points?
this glyph has a positioning information
okay.
to be attached here.
Right. Okay.
One of positioning
Right.
information to be attached
Okay.
You're using the OT anchor points.
Pardon?
You're using the open type anchors.
Yes.
Okay.
So these GPOS features.
Okay.
is
Okay.
applied.
Gotcha.
So in this example here, the vowel E above and the what is that, terminal Y, or I'm not sure what the last one is. You're just using the open type position directly.
Yes.
But in the Thai example that you showed earlier, when you had vowel with ba, you're moving it off of the default.
This part? Oh.
Yeah. So in this case, I guess what I don't understand is, like, are you actually able to move the little circle?
Or go to here.
Yeah, because normally if you didn't, this circle might fall right on top of the
Yeah.
stem of the blah, right? If you
Yes.
didn't.
So for processing this one, we at first convert this single character into a
Decompose it.
decompose it to this and this.
Okay.
Then do a reordering.
Okay. Okay. And then And then in M17, in FLT though, you could reposition this, or it's whatever
Yeah,
the
it
font
depends
says.
on what kind of font we are using. When we are using OpenType font, we perhaps apply some OpenType features to move this one in the correct place relative to this.
Okay.
But if we are using normal two-type font, it doesn't contain a G-post table.
Right, like an older type font.
Yeah, we have a special command to position the grid to the previous character by specifying some
X-line, some anchor point.
Yeah, using anchor point or doing some relative directed functions. This must be moved to the how to say but virtually we roughly about 12 anchoring points by default. So we can use those anchoring points to position it to the correct place.
So, okay, so if I understand this correctly, this is actually doing the similar kind of thing that graphite does.
Yes.
But
Except-
calling the OpenType tables when you want to. Calling the OpenType tables
Yes,
when you
yes.
want to.
And then the other difference is in graphite it's stuck inside the font, and here it's a separate file.
Here's a separate font, a separate file.
You have a
So
separate
you
file.
have a font, and then you have this compiled into a file.
Yes. This FLT can be a simple text file outside of the font. Or it may be possible to embed this FLT code into a TrueType table, like a graphite does, have a special engine.
So you have two, for tie, for example, would I have to have two rule sets? One for
Yeah, actually,
OpenType tie fonts and another
One
one
OpenType FLT and several other FLT for each font.
for each. Oh, for each legacy type font, I would have to
Yes,
have
yes.
a separate FLT.
Yeah, for example, for X window font, we sometimes X doesn't support the other decomposition of this one.
Right.
So what we can assume is just each font has just a character cell. Each grid is just a character cell. So we must apply the special FLT for that kind of font. And there is a very famous Norasi font.
Yeah.
Norasi font in Thai. And we have a special FLT for Norasi. So in that case, the FLT is doing exactly the same thing as graphite. It does. It contains the rules specific to the Norasi font. So, are there any questions? Any other question? May I? Okay, I will.
We're not here, but I think you've made a very good job of showing how complex it is.
So okay. Well, so what I hear you saying is, suppose if you have a font that already has good
Yeah.
OpenType support
Yeah.
in it, you can override pieces of the OpenType behavior. You can override parts
Override.
of
Yes.
the OpenType behavior and then use the parts that you want.
Yes, it's also possible. But usually we don't have to override OpenType tables, OpenType features.
Okay, so what?
What we do is just drive the OpenType features to the current input sequence.
Okay.
Yeah.
So if a font has good OpenType
Yeah.
tables, then what m17n really is doing here is allowing you to do the reordering and the other stuff that OpenType cannot do.
Yeah. What it does is the reordering, and we decide to which part of the input sequence which features apply.
So you basically found a way to do what's normally done in C or C++ code without
Yes.
special secret.
Yeah.
And then you also, though, like graphite, you also have classes, is that right?
classes.
So graphite, if we look at the graphite rules that Sharon showed earlier, there were classes. For example,
Yeah.
a class might say class for dotted
Yes, yes.
letters and a class for dotless letters.
And the similar thing is done by.
And that's what those
this
C-
Academy
That's
Glasgow.
the letters
It's
here,
the
the A, B, C, and D.
Yeah, and the difference is that we use these letters in the regular expression. So here, all these letters represent a set of characters.
Sets of characters, right?
So it's quite, this regular expression is also easier to understand when you know the knowledge of the structure of the script. Consonant, vector, non-derivable, something like this. This can be mnemonic.
You know, I don't know if you allow it, but there's a feature in some regular expression libraries, it came from Perl, of course, which is to allow white space and comments inside regular expressions. And I would urge you to consider it. Because it really does make them a lot easier to understand and maintain if you can have, if you can make your regular expressions be on multiple lines, single regular expression, and put comments by different parts of it.
Yeah.
If your white space includes a little
I'll say,
slash, then
yeah.
There's another feature in Perl, you can have character classes which are named. So instead of having H and C and R, you actually put in the word that says it's supposed to be.
Yeah.
Which is very good.
So you will see that this code is very easy to understand, but very slow, because we must try this expression first and next this one. And the header part is the same, so it's redundant computing. So it's also possible to make this regular expression into one by using lots of alternative parts here. So it's a trade-off for readability or the speed.
Although presumably a sufficiently high level of view could optimize and convert one into the other.
I don't understand what.
You can have both readability and speed.
Yeah.
If you can automatically convert the more readable form into the more efficient form.
Yeah, it's possible. But for the moment we don't have that kind of code.
Okay.
The complex CTO, the generators are on this.
It's good try. This it just use S expression. It's not a list.
Right.
Yeah, it's just a matcha and some special commands. So it's quite easy to convert this format into XML. It's one of our future work for making this converted to the XML and using the XML parser and whatever. But I think this format is more readable and also fast. No? Yeah, it depends. When you are
regular expressions or not.
Well, I would be very surprised if the time taken in loading the file is often significant compared to the time of actually using it. And therefore, once it's loaded, I mean, you've got the same memory representation, so there's no speed difference.
Yeah. So the speed of reading is just the first time only.
Yeah.
Yeah. So you're right, it would probably be it would probably take longer to read the file initially if it was in XML. But the extra time may not be very significant.
Yeah. Why would you want to put this in XML? I guess. Well, I'll tell you, okay, when I was looking from an outsider, having seen, I look at GDLs, and GDL looks like something that a linguist can understand. But I'm not sure that a linguist is going to be really thrilled with regular expressions.
Right.
That's my
That's
initial.
orthogonal to XML.
Yeah, for the same reason though, I wouldn't want to put it in XML because
Well, it doesn't make it harder, it doesn't make it easier for the linguist, I don't think.
So, GDL is sufficiently rich in its structure and syntax, it actually requires a compiler. So, if I'm guessing right, that stuff's basically interpreted at runtime.
Yeah, it sounds like that. And I think you
Okay,
actually do
right?
get...
I mean, so this is interpreted in load time every time, or you also have a compiler that runs this?
Yeah, it is interpreted as the first, it's passed into the internal structure as the first time only.
And then it's, after that, then it's interpreted that first time, and then it's...
But then if you reboot the machine, it'll get interpreted the next time.
Yeah, of course. Or restart the application.
Yeah.
Yeah. We don't have a
Okay. So when you start m17n, it's going to load all of the knowledge for all of the fonts.
No, it's just on demand.
On demand.
Yeah.
You do actually get an advantage with XML languages like this of people who are not computer programmers and who might not be using, for example, an editing with parentheses matching, which is that if you make a mistake in something like this, it's not always, I mean, it's very difficult to provide clear error messages to the user if you've left a bracket off.
Actually,
If you have XML, then you'll have an end tag that goes to the start tag, and the user can at least say, my error is inside this regular expression.
yeah.
Rather than at line 15,026, we say we've got 1, 2, 5, those parentheses, error.
I mean, I guess
Not Emacs. When we edit this part
Right.
by Emacs, there's no problem.
Right.
Much faster. And also, when we are running FLT, we embedded special routine to print out debug information. So what each stage is doing is shown like this, and it's quite easy to debug this FLT file. So anyway, may I go to this page? Yeah, this is some example of the parts of the other CPL programs. I use Fedora for 7 with m17n. This year part is correct. And GAD Pango, I don't know, perhaps this is not the latest one. Pango 1.16. It's out of these parts.
1.17 here.
1.17.
No, but it's not that different.
Yeah.
KD using Qt3 still. So perhaps the fix, I don't know. Anyway, this is some example of the bugs I found in the Fedora Plus 7. The red part is the actual bug, and the pink one is questionable. I don't know which is correct.
Is this one, the lowest one, is that Canada? The last?
I think, yeah, this is only here, so this is Canada.
So I will have to ask my colleague, because I think I have a colleague who reads Canada.
Oh.
And I thought she told me that the subjoined letters often are actually positioned, not directly, but actually you want them a little bit.
Yeah, but
Well, I'll have to ask her.
I checked I forgot the name of this font, and the font surely has a special GPOS feature that moves this part to here. So it perhaps I think gedit and OpenOffice is not applying that special feature for this sequence.
Is that possible? I mean, if it's just a regular GPOS?
I don't know. Yeah, and anyway, so the most indic FLT code is developed by just one person within 10 days or 2 weeks. So it can be a very quick prototyping. And for writing FLT, we don't need knowledge of programming language. What we need is regular expression knowledge and also the clear knowledge about how scripting should be drawn. So supporting the minority scripts is also quite easy with this one. The problem of FLT is it's not FTL. You know what FTL? Faster than light. Science fiction. We made an experimental Pango module with using the m17n library. It showed that FLT is 4 to 5 times slower than the original Pango C code. There are several reasons. The first one is the inefficient interface between this library and Pango. Currently, m17n provides only a very high-level API. So, and the Pango module is in a very low level. So, the interface matching needs some time. The next one is the slowness of FLT interpreter. Although the FLT is passed into the internal structure, but still the current code for running that driving the internal code is very naive. We have not yet spent any effort on tuning it. So there's a lot of room for tuning up in the interpreter code. And the other is the slowness of OTF handling. We are using libOTF, which we developed by ourselves too. But this code is also very naive. Yeah.
What does libOTF do?
Almost the same thing as half-pass does. So before, when we developed m17n library, there was no half-pass. Only free-type code for non-supported path. So we developed libOTF.
libOTF lets you open and read the open type tables and read all the features from it, right?
Yeah.
I don't think it doesn't actually do the shaping.
No,
it's like
it's just table access, basically.
Table access. Yeah.
Table access and also drive some feature to the specified sequence. So libOTF provides open type font and drive some feature on the sequence and get the result back to the m17n library. So the code is very naive and it's slow. And the last one is the slowness of FLT's algorithm itself. This one I showed you. For instance, this code is very slow by its nature. It does similar regular expression matching many times. So this can be automatically, it may be possible to convert it to the more rapid code automatically, or we can make a special syntax for readability and speed both. And the last, I'd like to ask a question about this part. Unicode 5.0 this syntax. It basically means that some explicit grammar is done by explicit zero-division joiner, or by absence of conjunct in the font. So depending on the font, we must place the pre-border to the different place. So to do that, we apply OTF features check the length of the resulting tree. If the length is just 1, it means that there is a ligature conjunct form. So we move the vowel to the before the conjunct form. But this Rohiti font has a conjunct form in just by 1 click here. So we can place this vowel in the first place. But some fonts represent the conjunct form by the combination of 2 clicks. So in that case, we put vowel here, but it's not correct. I don't know how to solve this problem.
I mean, it sounds to me like the Unicode 5 book is assuming that a font will only have, that there will be always a single glyph to replace, a single glyph representing 2 half forms. But in fact, Canvas, which is a very good font, has two half form glyphs.
Or it assumes that there are some underlying font provide the information that they have a conjunct form or not. But as far as I know, with OTA, I don't know how to check if the result, some open type forms have a conjunct form or not. All we can do is just try to apply some
Well, I
feature.
think you have to do it like you have to do for some of the other scripts. You have to move it to the front, run all the substitutions, and then check to see if you have to move it somewhere else.
Yeah, but
It's kind of a pain.
after we check, apply some feature, we don't have a knowledge about generic knowledge about font. So which part is actually the conjunct form, or which part is the different form? I mean the non-conjunct form. If the conjunct form is represented by 2 clicks. I think there's no way to solve this kind of problem.
I have to say that rule is a complete surprise to me.
Doesn't that rule seem rather...
It seems wrong.
Yeah.
Speaking as someone who can't speak enough Hindi to get my way out of a paper bag. It's just contrary to everything I thought I knew about how that script works.
I mean, it seems like what they've done in Canvas is a little bit unusual, but if it results in the right appearance on paper, it's only a little bit unusual because right, you're saying they have 2 half glyphs. They have 2 glyphs representing the left and the right half of that literature.
Yeah, this is the valid conjunct form for this part.
Yeah.
But it is represented by 2 clicks.
They probably did that because it makes sense that left side.
Well, also that's the sort of thing you had to do if you were before OpenType when you only had 256 glyphs to play around with. That's what I get for not reading the English font list too much.
So anyway, I quickly explain the IFLT. This is our website and this is the email address. To write mail to here, you have to register. So if you don't want to register, just write to me directly. Okay, so this is my talk. Do you have any questions?
Hey, well, thank you. Yeah, I think we're now at 10 minutes past 6, something like that.